Everyone, in this video, I will explain my implementation of four classical symmetric encryptions ciphers, uh, which are the Ceph cipher, the multiplication cipher, the Vigenère cipher, and the columnar transpositions cipher. So I will describe my approach, the structure of my code, and then show the example outputs demonstrating encryption and description working correctly. So the assignments require building a program that encrypt plain text using the four ciphers. Decrypt cipher text back to the original text. Use ASCII numbers for character conversion, and successfully demonstrate three samples execution. So these ciphers are on symmetric, which mean the sender and the receiver share the same key for both encryption and decryption. So in my code, I create separate functions for encryption and decryption processes so that each ciphers can be tested independently and clearly. So for my approach and cipher design, for the SIF cipher, mm, so for the SIP cipher, actually this is the simplest model. So each character is converted to its ASCII number, and I apply this one. It's like C equal to uh, P plus K. And multiply 256, yeah. And so the description subtract the key. This works for all characters, including punctuations and spaces. Secondly, it's for multiplication ciphers. This cipher multiplies ASCII codes. It's like C equal to K plus B, and mod by 256. And description require the modules inverse of K. So I implemented an extended Euclid algorithm to compute that inverse. This ensures the cipher remains reversible. So for the Vigenère cipher, the Vigenère cipher use the repeating key string. So each plain text character is shipped by the ASCII values of the key character. So, for example, like Ci is equal with like Pi plus Ki um mod by 256. Yeah, so the description subtracts the key character. This make the cipher uh polyalphabetic, meaning like the same letters encrypt differently depending on position. And for columnar transposition cipher, so these ciphers will rearrange the order of characters instead of modifying them numerically. So my approach, um, I write the plain text row by row into a grid, and then sort columns beyond the alphabetical orders of the key, and read the characters column by column to generate cipher text. Description reverse this process by reconstructing the grid column order. So for the code structure, all four ciphers have two functions each for encrypt and decrypt. Yeah, like for the shift cipher, I'm going to shift encrypt and shift decrypt. And then this one for the multi transposition, like this one is like encrypt, and then we have decrypt. So for each one, so this keep the logics module and easy to compare. Then I create a loop that run three different plain text example. This one. Yeah, hello world, 123 something, ICTS 503 cryptography. Yeah, this one. And for explain text, the program gonna convert text to ASCII and then applies the four ciphers print the encrypted results, decrypt cipher text, and print the recovers plain text. So this verify the correctness because the decrypted text always match the original input. Um, and for the sample execution, so when the program runs, it print the following for each test message. For the shift cipher, um, show the readable transformation because it's simply shift the ASCII codes. Description immediately return the exact plain text. For the multiplication ciphers produce more unusual symbols since multiplication spreads values across the full ASCII range. Using the module inverse ensure the proper description. And for the Vigenère cipher, it produces complex pattern of characters because the key cycles through the message descriptions reverse each ship correctly. For the Chalmers transposition, produce a scramble-looking message but preserve character frequency. The decrypt output return exactly to the original message. The notebook prints clear separation between execution and all the three test cases successfully show encryption followed by correct description. So to summarize, I implemented own for classical symmetric cipher using ASCII-based arithmetic. Each cipher includes matching description function. My program run three different samples messages and print both encrypted and decrypted results. In every case, the decrypted text perfectly match the original plain text, proving the correctness of the implementation. Thank you for watching my explanation of the four fundamental ciphers project.